Hello, the title of this work is Determination of the Gravity Wave Parameters Observed in the Brazil Equatorial Region from Fabry-Perot Interferometer. This work was developed in the Federal University of Campina Grande, Brazil. The main motivation to this work is that in general, when the temperature measurements collected from Fabry-Perot interferometers comes from different parts of the sky. Thus, we can use this technique to investigate the passage of the gravity waves in the thermosphere of the field of view of the instrument. On right, we can see a Brazilian map where the two Fabry-Perot interferometers were located, one of them in São João do Cariri, another in Cajazeiras. This experiment was designed by Jonas Makela and John Merweda, where the main objective was investigate the dynamics of the lower thermosphere by measuring wind and temperature in the equatorial region. The present work aims to determine the parameters of the medium-scale gravity waves observed in the northeast of Brazil in the thermospheric temperature observed from the Fabry-Perot interferometer deployed at São João do Cariri. The methodology consists basically in using the data from the Fabry-Perot, make an interpolation of 10 minutes. After that, we remove the daily cycle from a 30-day wind, and then we can look for periodicity between 30 minutes and 3 hours, which correspond the periods of the gravity wave that we are interested in. We use also long discargo and wavelet analysis in order to look for periodicities in the 4 cardinal points with 15% of similarities, calculate the period average, and using the analysis harmonica to estimate the amplitude, horizontal wavelength, propagation direction, and horizontal phase speed of the gravity waves. This slide shows in details how can we estimate the horizontal parameters of the gravity wave. After find the desired periodicity, we use the phase difference between the north and south measurements for the meridianal component, and for the zonal component, the phase difference between east and west. We use a kind of least square straight line fit to estimate the wavelength in meridian and zonal direction, and using these formulas on right, we can estimate the horizontal wavelength, the propagation direction, and horizontal phase speed. We are going to show here a case study observed on 4 May 2013. This figure shows the temporal evolution of the nighttime temperature measured at São João do Cariri from north blue, south orange, east green, and west red. This was an interesting day because it was in an ascending solar activity period with solar flux of 131 solar flux in units. It was observed that Kp index equal 2, which corresponds to a geomagnetic quiet day. After applying the proposed methodology, it was possible to see a peak of 2.3 hours above of the significance level of 95% for all cardinal points, as we can see on right in those charts: north, east, south, and west. Using wavelength analysis, of course, the results were similar, and it was possible also to see that the gravity waves or the periodicity was present along the whole night. All these measurements shown in this figure are within the cone of influence. Another important aspect here is that, for example, the measurements for the 4 cardinal points are not equal sample. I mean that, for example, there is more points collected in the north and south. Of course, it will depend on the condition of the sky. The chart shows the less square feet for the observed periodicity. The light gray line shows the daily fluctuation in the temperature, while the heavy black line shows the filtered fluctuation, and the cyano line represents the reconstructed wave using the estimated parameters. This table summarizes the parameters of the gravity wave observed during this night over São João do Cariri. We calculate a period of 138 minutes, horizontal wavelength of 408.9 kilometers, the horizontal phase speed of 53.2 meters per second. These waves are propagating to the northeast with a 56.4 degrees from the north and an expressive amplitude of 10.7 kelvins. Conclusion of this work and the remarks: measurements of the temperature in the thermosphere obtained from OI 6300 air glow emission from a Fabry-Perot interferometer were used to investigate the passage of the gravity waves over São João do Cariri on 4 May 2013. The present method showed confident results for the estimation of the horizontal parameters of this medium-scale gravity wave, which had a period of 138 minutes, horizontal wavelength by about 490 kilometers, amplitude of 11 kelvins, and propagated to the northeast of Brazil. Those parameters are consistent with previous observation of MSTID observed at the same place. Although the present method appears as an interesting tool to investigate medium-scale gravity waves from Fabry-Perot measurements, there was a big challenge in finding simultaneous good measurements for all cardinal points which could be associated with the semi-periodic structure investigated. I'd like to thank you to the CNPq from Brazil for supporting the research, the Federal University of Campina Grande for supporting my presentation in this meet, and thank you for your attention.